Yeah, hello everyone. My name is Tasneem. I'm the senior manager at 98 percentile in the HR department. And today we did a wonderful drive with XLR. It was amazing right from the very beginning, from the very first day when I got in touch with them till today. I think it was an extremely smooth journey with them. There were multiple follow-ups done by the representatives in order to check that we would be, what time we would be coming, how many people would be coming, what vehicle we would get. To that extent, they were so precise in giving all the information to us. It was extremely great to get associated with them and have a drive at XLR campus. So we are very, very happy that we got a chance to do this. Now, coming to the students, what XLR had, I think they were extremely enthusiastic. They were well prepared. They were aware of what they are coming for. I think there was some back-end preparation which they did that was commendable. They also were very confident and they were open to any kind of thing we were asking them to do. That was I think the best part. Now, I really hope we have a very, very fruitful association with each one of them and XLR in future. We are really looking forward to have many more drives like this.
Hi everyone, my name is Prachi Sharma and I'm the Senior Project Manager for IT Department at 90th percentile. So today we were here for this IT bootcamp, right, this technical drive and at XLR. So it was a great experience and I would feel that the students, they are the freshers, right, but it doesn't seem like that. So if I talk about their technical and cognitive ability, they all seem pretty good in that and that's what I felt. And I guess they have been taught pretty well at XLR, so that's how they have performed good in their aptitude and the technical tests. So I wish them all the best, and it was a very great experience over here.
from 98th percentile. We visited XLR for the campus placement drive and it went very well today. Miss Ambika, Miss Pragati, everyone received us greatly here and we had a lot of enjoyable time here. The students even had great experience with us. They were interactive, they had good aptitude and all the technological skills they showed. I think they were all well and we really appreciate their time that they spared to us and I think we will be doing a great job. We are expecting a lot of people to be hired from them. Let's see. It was a great experience altogether.
Thank you.
Thank you so much.
From entering into the cyber tower to exiting out of this tower, the XLR team has been received me with such a care and pleasure.
I am the part of this XLR since 4 months. From the third month itself, they have conducted the placement sessions from the third month itself, and this is the fourth month, and this is the 98th percentile is one of the placement drive I have attended so far, and attending to this drive is such a good experience for me. All the HRs and the team made us feel very comfortable and confident.
XLR helped me a lot and I experienced a lot of things today. So I'm really hope to be I placed in that company. I'm confident about that. Thank you.
Am I audible to all of you guys? Okay, great. Let me share my screen. Okay, guys. So I hope my screen is visible to all of you, right? Yeah, good evening to all of you guys. Okay, so let's begin with the session, guys. In the last session, guys, we have discussed things related to the NLP, natural language pre-processing, and we saw how we can handle the text data. And also we saw a couple of terminologies like what is a document, what is a corpus, and what all are the data pre-processing steps with respect to the text data, right? And also we saw how you can, convert text data to its vector equivalent or numerical equivalent. And that is something we called it as a vectorization. Right? So let me just remind you that workflow, how it begins with. So if I have a text data, which is my input text data, so first of all, we need to apply the text data pre-processing to clean this input text data, right? So what are all things comes under the data pre-processing with respect to text data? That is nothing but removing the punctuations, removing URLs, removing the stop words, lemmatization, tokenization, and so on. So what we do, the first step we apply with the text data pre-processing. And once we pre-processed our text data, so the output is our clean text data. And over this clean text data, we apply some kind of a vectorization technique. What this vectorization technique will do, it will convert your clean text data into its vector representation or numerical equivalent. So can you guys name a couple of vectorization techniques? Do you guys recall? Anyone? Yes, TF-IDF is one kind of a vectorization technique. Exactly. Binary weight, bag of words, TF-IDF, right? Yes, word embeddings, word to vec, CBOW, skipgram. So all of these are the vectorization techniques. Yes, Mohit. Okay, so the output of vectorization technique is nothing but your vector representation of clean text data. So vector representation is nothing but the numerical equivalent of your clean text data. And once we get the numerical data, then over this data, you can apply whatever statistical analysis or whatever modeling techniques you want to apply, you can apply over this numerical equivalent of your clean text data, right? So this is something what we have as a flow diagram with respect to our text data analysis, right? So up to this point, guys, any doubt or any questions, anyone? Okay, great. So guys, the agenda for today is basically, first we are going to see one of the application of NLP, which is sentiment analysis. And once we complete this particular analysis, then we'll move towards our new topic, that is the neural networks, right? Which is a backbone of the deep learning. So let me start with this sentiment analysis part. Okay. So guys, this particular analysis or case study I have taken as a war sentiment analysis. And in this particular analysis, we are going to analyze a data set which is related to the Russia-Ukraine war. I'm sure all of you guys know at least some details regarding this particular event, Russia-Ukraine war, right? So we have a text data, which is nothing but the tweets done on different platforms by different users related to the Russia-Ukraine war in different languages. So we are going to analyze the sentiment of users over this particular topic called Russia-Ukraine war. That's why we are calling this analysis as a war sentiment analysis, right? Yeah, Ayushman. Okay, so but before starting with this analysis, guys, let me tell you. So for sentiment analysis, if you want to perform the sentiment analysis, so you can adopt a machine learning technique, or you can also adopt deep learning or AI-based technique, right? You can adopt any one of the technique. But to work with the deep learning or AI-based technique, you should be comfortable with its basic understanding. So for the time being, I am not discussing the things related to deep learning or AI. We are going to analyze the sentiment for this war sentiment analysis part with respect to the machine learning techniques, right? This is one thing. Now, when it comes to the machine learning part, so there are a couple of sentiment analyzers are available. You can adopt any one of them and start analyzing the sentiments. But it has been found that there are 3 to 4 most popular sentiment analyzers are there. One of them is known as a TextBlob. TextBlob. So it is one kind of a sentiment analyzer which will analyze the sentiments for given input text data. There is another sentiment analyzer that is called as a VADER. VADER is another powerful sentiment analyzer that is being used to analyze the sentiments or emotions of the user. Another sentiment analyzer is Affine. Affine is another sentiment analyzer. So like that, we have a couple of other sentiment analyzers, but most popularly used sentiment analyzers are TextBlob and VADER. So in today's analysis part, we are going to discuss these 2 sentiment analyzers, and I will show you how you can apply these 2 sentiment analyzers separately and how you can interpret the result, right? So, okay. So first of all, I'm going to start with the TextBlob. And if you want to, use the TextBlob as a sentiment analyzer, first of all, guys, you need to install this particular library called TextBlob. Since I have already installed this particular library, so I have made this particular, code as a comment. What you can do, you can remove this hash shine and run this code. So if I put hash shine before any line of the code, that line will become comment, right? I'm sure all of you guys know what is a comment, right? And if you remove the hash shine, it will become a code. So let me just show you. If I remove the hash shine before the first line of code, so right now it's a comment one. So if I remove this one, now it will become a code, right? So since I have already, installed these libraries, so I'm not going to run the first cell, but you guys need to install this particular library called TextBlob. Okay, so there is one question. What is a sentiment analyzer? Okay, so sentiment analyzer is a tool which will analyze your input data, which is in text form. So it's like whatever in text input data you have, input text data, whatever input text data you have, we will pass this text data into the sentiment analyzer. Right? Sentiment analyzer. What this sentiment analyzer will do? It will tell you what was the emotion or sentiment of the customer was, or the user was, whether the customer was feeling happy or customer was neutral about that particular topic, or the customer was not happy over this particular like topic or whatever situation is going on. So in our case, the topic or situation is Russia-Ukraine war. So over this particular topic or situation, what was the sentiments of the users across the globe, right? So this is something we are going to analyze. And this sentiment analyzer, as I told you, there are a lot of sentiment analyzers are available. But in today's session, we are going to discuss two most powerful sentiment analyzers, which are the TextBlob and VADER. Okay, is that clear, guys? There is one question. Does this sentiment analyzer require any kind of a pre-processing? So I guess your question is related to the text data pre-processing, right? So if you recall last session and today's session also, so I have mentioned that when you are dealing with any kind of a text data analysis, you need to perform the text data pre-processing. Doesn't matter whatever is your problem statement. So the workflow will be the same. Your input text data, and then you need to apply the pre-processing, which is with respect to the text data. Then you need to apply the vectorization. And then you need to apply whatever technique or modeling or analysis you want to do over this numerical data. So these three blocks will be same for almost all kind of analysis, right? Yeah. Any other questions, guys, or we are good to go? Just a minute, let me also check it with YouTube, guys. Okay, guys, so let's proceed. So first of all, guys, what I'm doing, I'm just importing the required packages and libraries, right? So I'm importing pandas, numpy, I'm importing NLTK, from NLTK corpus, I'm importing the stop words, lemmatizer, tokenizer, and okay. So as I told you, since in this case, first of all, we are going to analyze the sentiment like analysis using the TextBlob, and then we will analyze the same input data with the VADER sentiment analysis. Sorry. Sorry. Okay. So this is what I'm doing. First of all, I'm importing the TextBlob. Under this library called TextBlob, we have the method called TextBlob. And if you want to use the VADER sentiment analyzer, so under the NLTK, we have a module called sentiment. Under this, we have another module called VADER, in which we have a method called sentiment intensity analyzer, which is nothing but the VADER sentiment intensity analyzer. So in that way, I'm importing the required libraries and functions. Right now, let me just show you our data set. I'm sure all of you guys know how to import a data set into your Jupyter environment. We have already discussed that part. So guys, this is our data set, and this is the head of our data set, right? It's not a complete data set. It is head of our data set. That's why you are seeing top 5 rows only, right? So what this data set contains, we have a user ID, which is a unique user ID for different users across the globe. Whatever tweets done by these users, we have these tweets as a text information. And as I told you, all of these tweets are related to the Russia-Ukraine war, right? And like this is the couple of starting words, right? It's not a complete tweet. So due to the space consideration, so you are seeing some starting words of these tweets. And then the third feature is the language, in which language the tweet is made. For English, we have a short form as a EN. Likewise, we have a tweets in different languages. Okay. And in total, how many records or rows we have? So here you can see I have done data.shape, and it is showing there are around 10,000 rows or 10,000 tweets we have with 3 features. And what are the 3 features? User ID, tweet, and language, right? So in total, we have a 10,000 tweets. Now, out of these 10,000 tweets, we have a tweets in different languages. So for this analysis, we are going to analyze only those tweets which are in English language so that we can understand, right? Okay, there is one question. What is import RE? Guys, RE is it is a short form for regex. Regex stands for regular expression. It is one kind of package is available in the pandas. In the Python, which is very useful when you are dealing with the text data. Now, what this regex will do, or this package RE stands for regex. This regex will do, it will identify the patterns present in your text input data. So if you want to identify some kind of a patterns is like, let's suppose you want to identify certain numbers or special characters. So all of those identification or detection you can do with the help of this particular library or package called regex. In short, it's a RE, right? And it stands for the regular expression. Okay. Yes, Ayushman. It is somewhat similar to that one only. Okay, guys. So this is what we have as an input data, right? Now, you can see here, guys, I have used a particular method called value underscore counts over this language variable or language feature. So what this method will do, it will give you, based upon your different languages present in this language column, the total number of records for each and every language, right? So as I told you, there are multiple languages present in this particular data set. So one of the languages, English, for which the short form is EN, what you are seeing here. Likewise, for French language, the short form is FR, which is present. And by applying this particular method, value underscore counts, what it will do, for each and every language, it will tell you how many total number of records or tweets are there. So this is something I'm getting. So you can see here, in total, I have a 10,000 records out of 10,000. For English language, I have a more than 8,000 tweets, which are there in this data set. There is some other language for which the short form is IT. For that, I have a 477 tweets. There is another language, PT. The short form is PT. I don't know which kind of a language it is. For that, there are 302 tweets, and likewise. So for French, there are 32 tweets which are made in a French language in this particular data set. So likewise, I got like for each and every language, how many total number of tweets are there. Since we are going to analyze the tweets which are only in English language, so that means we are going to analyze only these many tweets, 8483. These many tweets we are going to analyze, right? So how to filter out these tweets which are in English language? So for that, what you can do, okay, what you can do, so here I'm applying the condition. What is the condition? For this language feature, give me only those tweets where the language is equals to EN. EN stands for English, right? So the word present here is EN. So in that way, I'm getting only those tweets for which the language is EN, which is the English. And then you can see here, I'm saving this output into a new variable called var_data, right? So you can check the shape of var_data, which is 8483. So up to this point, we have just filtered out only those tweets which are in English language, right? Now, guys, this is our raw data. This is our raw data. And we are going to, analyze this raw input text data as a sentiment analysis. So the first block, if you recall the flow diagram, is the data pre-processing with respect to the text data, right? Now, if you recall the last session, so there I told you there are a couple of ways you can perform the data pre-processing. Let me just show you that part also. So I'm sure you guys recall all of these things. So here what we have done, we have just converted all of these input data into one paragraph. Then we have performed the removing the punctuations and tokenization, stop word removal, and all of those things. And there I also told you this is not the only way to do the text data pre-processing. There are multiple ways you can perform the text data pre-processing. So in today's session, let me show you another way how you can do that, right? Okay. So guys, what I'm going to do, I'm going to create a user-defined function in Python. And what this function will do, it will perform all the data pre-processing part for me, right? So this is how I'm creating a user-defined function. So in the Python, we have a keyword called def. Def is a keyword to define a user-defined function. This is the name of my function, pre_process over the text data. And what the processing it will do? First of all, it will convert all the text input into the lowercase. And then this re stands for the regex. So regex module will identify these patterns if there are any in the input data set, and it will just remove these punctuations or these patterns. So that's why I'm using the regex module. And once I will I have done all of these things, then what I will do, I will just remove the stop words. So how I'm removing? I will only fetch those words which are not in the stop words, right? And then I can apply the stemming or lemmatization, whatever processing steps you want to apply. So this is how I am doing all of data pre-processing steps in a one single user-defined function. And according to your input text data, you can tune these processings. So I have just taken some random steps. I'm not sure whether all of these patterns are there in my text data or not. I've just taken some random steps, right? But according to your input data, you can change these, steps. So once I've defined my function, which is for pre-processing, then here I'm applying this pre-process function over my tweet column. So if you recall this war data, this is the war data I have, where I have a 3 features: user ID, tweet, and language. And out of these 3 features, user ID is of no use, language is of no use. I want to analyze the sentiment over this tweet feature. So the target variable is this tweet feature, right? So this is what I have done here. I have applied this user-defined function over tweet feature. So first of all, I have selected this tweet feature from this war data. And then I have applied this pre-process user-defined function, which I've created just above that. And then whatever output I'm getting, I'm just saving that output into a new feature called clean tweets, right? So now you can see here, this is what I'm getting as a output after applying the data pre-processing. So before applying the pre-processing, if you see, I have something called as a, at the rate, this at the rate, couple of words, letters are in caps, couple of words in small, right? All of these words are in capital letters. So all of these abnormalities are removed based upon this pre-processing. And now I'm getting this as a clean tweets. So in this clean tweets, you can see all of the words are in lower lower letters, right? And there is no at the rate or any kind of a punctuations present. Okay. So this is how I'm applying the text data pre-processing. You can also follow these steps also, right? Each and every individual step. So it's up to you how much you are comfortable with these approaches. Okay. And then what I'm doing, guys, I can apply the tokenization also. So you can see here, this is the user ID. This is the tweet column, which is the original tweet column in which I have abnormalities, right? This is the original language column. This is the clean tweet column after applying the text data pre-processing. So this is what I'm getting as a clean tweets. I can also apply the tokenization, like word tokenizer, and I'm getting the tokens for each and every tweet, right? From here also, you can remove the stop words or you can apply the lemmatization or stemming. So it's up to you. So what I'm doing here, over this token tweets, I'm going to apply the lemmatization. So it's another way to apply the lemmatization, right? Over the token tweets feature. So this is the feature where I'm getting the tokens, right? Over these tokens, I'm applying the lemmatization. And this is what the final output of, applying the lemmatization over token tweets. And I'm calling this new feature as a lemma tweets. That means lemmatization tweets, right? So in that way, you can perform the text data pre-processing. And as I told you, this is not the only way. You can also adopt the first approach, what we have discussed in last session. That means you can go through step by step. Okay. So guys, up to this point, we have done the data pre-processing part with respect to our input text data. And the final, clean data we are getting this one, lemma tweets, the feature with lemma tweets, right? So up to this point, guys, any questions or any query, any doubt, anyone? Okay, so which function you have used to add two new columns? Okay, and there is one more question. The token is called lemma. Okay, so just understand, guys. This was my original tweet feature, right? This was my original raw input data. Over this tweet feature, I have applied the text data pre-processing to clean my input data. By meaning of the clean the input data, I mean I have removed abnormalities like any punctuations. I have converted all these tweets into the lowercase, just like that. And then over this clean tweets data, I have applied the tokenization. So this is the tokenization. So this is what I'm getting, the tokens. Over these tokens, you can also apply the stop word removals, or in this case, what I have done, I have applied the lemmatization. So what lemmatization will do? It will make the words into its root form if there is any present, right? So this is the final clean tweets data I'm going to take as a input to the next step, right? But if you want, you can apply all of these steps into one single line of code, like just create a user-defined function and you can apply all of these steps into one function only. Or you can also follow the step-by-step approach, whatever we have discussed in last session. Okay. So this is what we have got as a lemma tweets, right? Now we are going to apply the sentiment analyzer. But before applying the sentiment analyzer, what you need to do? Okay. So guys, in this case, these TextBlob or VADER sentiment analyzer, what they do, they will internally do the transformation, I mean the vectorization, and then they will directly produce the output, right? So what I'm going to do now, I'm going to apply the sentiment analyzer over these clean tweets. And here the feature name is a lemma tweets. And let me just explain you how you can get the output and how you can interpret it. So how to download tools for execution? Guys, this is the code how you can install the these libraries for TextBlob, right? And VADER sentiment analyzer is available under the NLTK. So I hope this NLTK you have already installed from the past session, right? So this is how you need to install the TextBlob. And if you have already installed the NLTK, the VADER sentiment analyzer will be there. Okay. So let's see, guys. First of all, we are going to use the TextBlob as a sentiment analyzer. So to apply the TextBlob, first of all, let's understand what is this TextBlob and how it will generate the output, right? Then we'll come to this code. So guys, TextBlob is a lexicon-based sentiment analyzer. It is a lexicon-based sentiment analyzer. Now, what is a lexicon-based sentiment analyzer? So actually, these kind of a sentiment analyzers, they contains at the backend some kind of a dictionary where they have a multiple words. Number of words are there, different words are there, and they classifying these words either as a positive or negative words. Along with that, they will assign some kind of a score to these words depending upon how positive or how negative these words are. So this kind of a dictionary is present at the back end with this kind of a sentiment analyzer. That's why they are calling as a lexicon-based approach. For example, let's suppose in this dictionary, they have a two words. One is a good, another one is a best. So you can see here, guys, both the words is having the positive impact. Good and best, both is having the positive impact, but the intensity is different. If you are using the word best, right, that means it is having the more positive impact or the more positive intensity. With respect to the good is also is having the positive impact, but the intensity is little bit lower compared to the best. So probably I'm just taking some random values. So let's suppose the score assigned to this word good is, if it is a 3, so for best it will be somewhere around let's say 5, right? Same goes for a negative words. For negative words, they have a negative scores, and if the word is having the higher negative impact, the score will be more and more negative. So in that way, they have lot of words in this dictionary. For each and every word, they have classified whether the word is a positive or negative, and based upon its positive or negative intensity, they have the scores given to these words. Now, these scores were decided by neuroscientists and data scientists. And time to time, they update this dictionary, right? So it's not like it's a like static dictionary. So this dictionary is being updated time to time. Okay. So that's why it is called as a lexicon-based approach. So lexicon-based approach means the approach which at the backend contains some kind of a dictionary where we have number of words which are classified either positive or negative words, and based upon its positive or negative intensity, there is some kind of a score is given. So here I've taken just an example. So probably it's not exactly 5, maybe more than 5. But yeah, some kind of a score will be there. Is that clear, guys? What is a lexicon-based approach? Guys, material is already uploaded over the LMS portal. Okay. Please check the LMS portal. Okay, so yeah, any questions, guys, with this part? To understand what is a lexicon-based approach? Okay, so I hope this part is clear to you guys. So this is one thing. Second thing is, what do you mean by, Sumona, the only positive sentiments? As I told you, there are a lot of words. Some words are positive with positive impact, and some words with a negative impact. So here I have just taken a one typical example of positive sentiment or positive impact, right? So this dictionary is having a combination of positive, negative, as well as the neutral words also. Okay. So this is one thing, guys. Another thing is, if I talk about how this text blob will generate the output. So guys, in this text blob, we have two things. So you can get two kind of output from this text blob sentiment analyzer, which is a lexicon-based sentiment analyzer. One is polarity. There is something called as a polarity score. Another one is a subjectivity score. polarity score and subjectivity score, right? Now first see what is this polarity score. So guys, this polarity score, this score will be in between -1 to +1, right? The value of this polarity score will be in between -1 to +1. Like for example, it may be minus 0.328, or it may be minus 0.901. It may be plus 0. Let's say 510, or let's say 0.889. So the value of this polarity score for each and every input data or each and every document will be in between -1 to +1. This is first thing. Second thing, how would you interpret the these scores? So let's suppose you got the polarity score for your first document as 0. Let's say 813. How would you interpret this number? So the thing is, guys, if your polarity score is positive, then it will like that particular tweet or document is having the positive sentiment. If the polarity score is negative, then that particular tweet or document is having the negative sentiment. This is first thing. Now you can also identify how much positive and how much negative the sentiment is. Whether the customer was little bit unsatisfied or the customer was very much unhappy. So that is something you can, detect with the help of the score value. If the polarity score is close to -1, like -0.9, -0.87, -0.79, or let's say -0.889, something like that. If the polarity score is close to -1, so the sentiment is highly negative sentiment. If the polarity score is close to 1, like 0.78, 0.889, 0.95, something like that, then the sentiment of that particular document or tweet is highly positive, right? So in that way, we interpret the polarity score. This is one part. Second thing, what you are getting from the text blob is a subjectivity score, right? Let me erase this part. Okay, so the second score you can get from the text blob is a subjectivity score. Now this subjectivity score lies between 0 to 1, right? The subjective score you will get in between 0 to 1. If the score is close to 0, then it is called as a, like the tweet or whatever text data you have or document you have, that is called as a, it is having the objectivity. If the score is close to 1, it is called as a, the tweet is having the subjectivity. Tweet is having the subjectivity. Now, what is the meaning of this objectivity and subjectivity? So guys, if a score is close to 1, means it may be 0.78 or 0.91 or 0.98 or 0.88, something like that. The score is close to 1. The tweet is having the subjectivity, and that means subjectivity stands for whatever tweet is being made, that is the personal opinion. That is the user's personal opinion, right? And if the subjectivity score is close to 0, like 0. Let's say 0.1 or 0. Let's say 1.001, 0.0009, something like that. If the subjectivity score is close to 0, then it is said that whatever tweet is being made by the user, that is the factual information. That tweet contains some factual information. Right? This is the meaning of subjectivity and objectivity. Is that clear, guys? Any issue to understand any of these terms? Anyone? Okay, great. So this is what you can get from the TextBlob. Let me just show you how you can implement it. So since our final clean variable or clean text data is under the lemma tweets variable, so over this lemma tweets variable, we are going to apply the TextBlob as a function. So I have already imported this function at the beginning of this document, like this notebook. And then under the TextBlob.sentiment module, we are getting the polarity for each and every clean tweets, which is a lemma tweets. And I'm saving this polarity score under a new variable called TextBlob sentiment polarity. Likewise, I'm also getting subjectivity score, applying the TextBlob.sentiment module over this lemma tweets, and whatever subjectivity score I'm getting for each and every input tweet, I'm saving it into a new feature called TextBlob sentiment subjectivity. And here you can see that this is what I'm getting as a final output. So in the final output, you can see here, guys, this is the user ID, original variable, original tweet variable, language variable, and then this is the clean tweet where I have applied my user defined function to clean this tweets variable. Over this clean tweets, I have applied the tokenization. Over this tokenization, I have applied the lemmatization. And over this lemmatized tweets, I have applied the TextBlob as a sentiment analyzer where I'm getting the polarity score and the subjectivity score. Right? So you can see here the polarity score. So this polarity score lies between -1 to +1, any value between -1 to +1. Subjectivity score, any score between 0 to 1. Right? So you can see here, guys, for the second tweet, I'm getting the subjectivity score exactly 0. That means whatever tweets it is having some factual information. Right? So in that way, we can interpret. You can see the third tweet for which the subjectivity score is almost 1. It's a 0.9. So for this tweet, you can see that most of the things which is present in this tweet is something personal opinion of this particular user. Right? So in that way, we analyze the tweets with the help of the polarity and subjectivity. Okay. So up to this point, I hope you guys understood how you can interpret this polarity score numbers and how you can interpret this subjectivity score numbers. Right? Now see, guys, so you got the polarity score as subjectivity score, but how would you know finally that whether this sentiment is whether this particular tweet is having the negative sentiment or positive sentiment or a neutral sentiment? So for that, there is a one rule, and this rule is fixed. You cannot change these limits. The rule is for TextBlob, and this is only for a TextBlob, guys. For TextBlob, if the polarity score is less than 0, the sentiment is negative. If the polarity score is 0, it is having the neutral sentiment. If the polarity score is greater than 0, it is having the positive sentiment. You cannot change the threshold value 0, right? It is fixed in case of a TextBlob. So based upon this, threshold value 0, you can classify whether your sentiment is whether your input tweet is having the positive sentiment negative sentiment or a neutral sentiment, right? So this is what I have done here. So based upon my polarity score, whatever polarity score I have for each and every, input tweets, I have just created a new column where if the polarity score is greater than 0, it is having the positive sentiment. If the polarity score is 0, it is having the neutral sentiment. If the polarity score is less than 0, you can see here it's a minus 0.08. So it is having the negative sentiment, right? So in that way, you can detect whether which tweet is having the positive or negative sentiments, right? And this is what I have done one more analysis. After applying this, positive, negative, or neutral sentiment tags, so now I have all applied value underscore counts method over this variable so that I can get an idea out of 8483 tweets, how many total positive tweets are there, how many total negative tweets are there, and how many neutral. So you can see here, guys, most of the tweets is having the neutral sentiment, neither positive nor negative. And then second one is like on the second number, we have most of the tweets as a positive sentiments, and there are few tweets which is having the negative sentiments. So this is how you can apply the TextBlob as a sentiment analyzer. Okay. Nikhil, this is what I have explained just now. What is the polarity score means? Just a minute. Let me explain you once more. So guys, this polarity score is nothing but you can get this score in between -1 to +1. This is first thing. Second thing, if the polarity score is positive means it been in between 0 to 1, then it is having the positive sentiment. If the polarity score is negative, then that means the tweet is having the, or the user is having the negative sentiment. For example, you can see here, let me take this example or this example. For these two tweets, the polarity score is negative, right? So you can say that these users, this user and this user, these two users is having the negative sentiments or negative emotions with respect to the Russia-Ukraine war, right? Now, how much they are negative or how much they are positive, that is being judged by these numbers. If the polarity score is, let me just draw a number line. So here you have a 0, here you have a -1, and here you have a, let's say, +1. If the polarity score is close to -1, somewhere like in this place, that means user is having the highly negative emotions, right? User is very much unsatisfied with the topic or with the situation. And if the score is close to +1, the user is having the highly positive sentiments, right? Somewhere like this, in this range. So it is having the highly positive sentiments. And in this range, if the score is close to -1, high negative sentiments. This is what you can judge from this just by seeing these values, right? You can see here this tweet number 3, for which the polarity score is 0.8, which is close to 1, right? So we can see that this particular user is having the highly positive sentiments over this particular Russia-Ukraine war, right? So this is how you can, interpret this polarity score. Is that clear, guys? Any doubt with anyone? Are you guys getting all of these things? Okay, so most of you guys are getting right. Great. So this is one part, guys. Great, great. Now let me also show you how this VADER sentiment analyzer works over the same data, right? So the data pre-processing or data cleaning part will be same. That means I'm directly going to use VADER sentiment over this particular variable called lemma tweets. Okay. So let me just show you. Okay. So this is what I have, something called as a VADER sentiment analyzer. It is again a lexicon-based sentiment analyzer, which at the backend contains number of words and whether the word is positive or negative with their scores, right? So it's a lexicon-based approach. And when you are going to apply this VADER sentiment analyzer, let me also tell you the full form of this VADER. So this VADER stands for valence aware dictionary and sentiment reasoner. Right? So this is the full name of this VADER. So all right. So V for valence, A for aware, D for dictionary, E stands for sentiment, E taken from here, and R for reasoner. Right. So this is the full form for VADER sentiment analyzer. As I told you, it is again a lexicon-based sentiment analyzer, and it will tell you how much positive or how much negative or neutral the sentiment is. Right. Now, when you are applying the VADER sentiment analyzer, in the output, you will get a couple of things. Let me delete this part. So guys, you will get a couple of things. Let me directly show you. Okay, let me explain first. So guys, you will get positive score. Let's say POS score. You will get negative score. You will get neutral score. And there is something called as a compound score. So guys, when you're applying the VADER sentiment analyzer, for each and every tweet, you will get these 4 scores. That means how much positive a particular tweet is, or whatever input data you have, whether it is a tweet or feedback or review, whatever you have. The same tweet or feedback, how much it is a negative, how much it is a neutral, and there is something called as a compound score, which is the normalized score of all 3 scores. Right? It is a normalized score of all these 3 scores. So in that way, you will get these 4 scores for each and every tweet. So what is the benefit of using the VADER? For a particular tweet, you can directly identify how much it is a positive and how much it is a negative. And you can also see that how much it is a neutral. Right? So you can see all of these 3 components for same tweet. Right? Where in the case of TextBlob, you can only see whether the tweet is a positive or negative. Right? So here I'm applying the sentiment intensity analyzer. So I have already discussed this is a VADER sentiment analyzer. And what I'm getting for each and every lemma tweets, which is the final tweets column, I'm getting the positive score, negative score, neutral score, and compound score. And I'm saving all of these score into a new variable called VADER positive, VADER negative, VADER neutral, and VADER compound. And you can see here. So after applying this VADER sentiment analyzer, this is what I'm getting as an output. This is the original tweet variable I have, right? So I have removed all of other variables, right? So that I can, show you the output in the same window. And these two outputs which I'm getting from the text blob, right? These two are the outputs which I've got from the text blob, like polarity and sentiment, the positive one, negative one, neutral. And this is what I have got from the VADER. So VADER positive score, VADER negative score, neutral score, and compound score for each and every tweet. So you can directly see that how much positive, negative, or neutral the tweets are, right? So this is how you can get the VADER scores. And then you can also classify whether the tweet is having the positive sentiment, negative, or neutral sentiment. And for VADER, guys, this classification is being made with the help of the compound score. Whatever normalization score it is generating, that is the compound score. And this threshold is fixed. You cannot change this threshold, right? So in case of a text blob, it was 0. So if any a polarity is less than 0, that was a negative. If it is the greater than 0, positive. In that way, we have in text blob. But in case of a VADER sentiment analysis, if the compound score, let me just show you from here. Let's suppose this is we have a 0. This is something we have a 0.5 plus we have a minus 0.5. So in case of a VADER sentiment analysis, if the compound score is greater than or equals to 0.5, that means this part, then it is called as a positive sentiment. If the score is less than minus 0.05, that means this region, it is called as a negative sentiment. And if the score is in between these two range, that is called as a neutral sentiment. Right? So this is how we classify whether the tweet is having the positive sentiment, negative sentiment, or neutral. And these thresholds are fixed, guys. You cannot change these values, right? This threshold 0.5 is fixed in case of a VADER. So this is what we have done. And this is the final, output I have got. So you can see here, this is the sentiment analysis by VADER. This was the sentiment analysis by the text blob, right? So this is what we are getting for this particular input data, right? So this is the complete analysis what I have with respect to sentiment analysis. This is also part of PhD research topic. So only sentiment analysis is not a part of PhD research topic, Sumona. It is one subtopic, you can say that. So NLP is a complete research topic, right? So in NLP, we have a number of things. One of the thing is sentiment analysis. And apart from that, we have a couple of other things. There are a lot of things actually, right? Is that clear, guys? Just a minute. Yes, you can take multiple conditions using LF. Yes, Himanshu. TextBlob and VADER, these two, sentiment analyzer will give you two different outputs. You need to manually, check which of the output is having the, correct explanation with respect to your text input data. Sometimes TextBlob will perform much better than VADER. It totally depends upon your input data. Sometimes VADER will perform much better compared to TextBlob. So totally depends upon what input data you are dealing with. Since I have explained you, these are the lexicon-based approach, right? Okay. So this is one part, guys. Just a minute. Creating a library function is PhD topic like TF, IDF. Aishman, I didn't get your question. Creating a library function like is PhD topic. I didn't get your question. As I told you, in PhD, you want they won't allow you to work over a subtopic. In PhD, you will work over a complete domain. So domain is NLP, natural language processing or text mining, right? TF IDF is just one particular concept. Great, Sumona. Okay, guys. So give me 1 minute so that I can prepare with the next topic, and that is the neural network, right? Just give me 1 minute, guys. Just a minute, guys. Give me half a minute. Okay, guys. So there is one question: why we are, discussing the text data analysis too much? So answer to this question, guys. Since our, the topic of focus is generative AI, and if you recall, guys, the first session, the introduction session, so there I explained you in a very crystal clear manner. The application, most of the applications of generative AI is with respect to the text data only, right? So you should understand how to handle the text data properly before getting into the generative AI part. So, and since the generative AI is the some advanced concept or one step ahead or deeper concept of the deep learning or artificial intelligence, so you should also understand the basics of the deep learning, that is nothing but the neural network architecture. So we have done with the text data understanding part. Now let's start with the understanding the neural networks. Okay, so that you can understand the other architectures also. Okay, so let me share my screen, guys. Could you please tell me the roadmap of the topics we are going to study in this? Okay, sure. Is it visible, guys? Okay, great. So let me tell you guys the roadmap for this particular, short-term course over generative AI and ChatGPT. So, okay. So from today onwards, we are going to start with the neural networks parts. And today and tomorrow, we will understand the neural networks, and then we will do one hands-on exercise how you can design or the neural network architecture and how you can analyze the outcome. So this is something for today and tomorrow session. And then from day after tomorrow, we will start with some advanced deep learning networks. Like we will start with the RNN. And then we will see, the modification is being done over the RNN with some advanced version of LHTM and GRU network. So once we understand these, neural network architectures like RNN, LHTM, and GRU, and then gradually we will move towards the what we are calling as a sequence to sequence model. We will also see, if I get the time, I will also discuss the basics regarding the transformers. With attention mechanism. And then I will show you how you can, do the same sentiment analysis with deep learning techniques or AI-based approaches. So whatever sentiment analysis we have done in today's session, likewise, we will do similar kind of analysis by using any of these, architecture like either RNN or LHTM or transformer or sequence to sequence model. That is something I will decide later on. But yeah, I will show you how you can use these generative AI techniques to do the sentiment analysis, right? And once we have done this part, then last 3 to 4 sessions, I will dedicate over the ChatGPT. So you can see around 4 sessions almost. Last 4 sessions will be on ChatGPT, and there I will show you how you can effectively use ChatGPT in different domains or areas. And I will show you what are the different, applications and functionalities of ChatGPT, how you can, make your task easier with ChatGPT with respect to different platforms, the application of ChatGPT with respect to the business case, with respect to the social media, how you can use ChatGPT for your data analysis and data science perspective. And I will also show you something called as a prompt engineering. So that is a very important concept under the ChatGPT, and that is something we will discuss in a very deep, in a deeply manner, like very intense discussion we will do over the this prompt engineering part. And then I will show you other AI-based chatbots. So ChatGPT is one of the AI-based chatbot. I will show you other AI-based chatbots and we'll do some comparisons also. So this is the roadmap, how we will progress. Right? Okay, so this is what, welcome guys. Sumona, RNN reinforcement neural network is something different part. RNN stands for recurrent neural network. Right? Reinforcement is it's another domain of deep learning, which is you can say it's some advanced concepts of the deep learning, right? So reinforcement learning, we are not going to discuss in this particular course. We will discuss recurrent neural network. Okay. So this was the course outline which we are going to follow. Now let's see, guys. Let's understand the neural networks and see the other aspects. Okay, so before starting with neural network, let me just show you how it looks like. So let me just remind you what we have done with the text data. So what we have done, we have the input text data. We pass this text data to a particular, you can say, one block, and that was the pre-processing. And we have done number of steps under this pre-processing. And the output of this pre-processing will become input to your, depending upon your need, it may be vectorization, right? And then we can apply different kind of techniques or analysis what you want. But in case of a sentiment analysis, we have directly applied our a lexicon-based sentiment analyzer over this pre-processed data. Right? So this was the you can say how data is flowing in case of a text data pre-processing when it comes to the machine learning part and all. Let's see how things are arranged in case of a neural networks. Neural network is, guys, it is the backbone of the deep learning or AI-based approaches, right? Now, what happened in the neural network? Here we have a different layers. You can consider these layers as whatever boxes we have just discussed, right? So let's suppose you have an input data. We pass this input data to our first layer. Let's say it is a layer 1. Then whatever output we got from layer 1, that is the input to the layer 2. Let's suppose we have another layer, layer 3, and so on. And finally, we have a last layer, which is our, let's say it is our output layer. Even input, this input data is fed to the, there is something called as an input layer. Right? So here we have a terminologies in terms of the layers. So we have an input layer where we have our input data. This input layer data get input to the next layer, which is a layer 1. Layer 1 will do certain kind of a processing. Whatever output layer 1 will generate, that will be the input to the layer 2. Layer 2 again will do certain kind of a processing, and the output of layer 2 will be the input to the layer 3. Let's suppose we have only these, layer 1, layer 2, layer 3, these 3 layers, and the output of layer 3 will be the input to the output layer. Output layer will also do certain kind of a processing, and it will generate the final output. So in that way, the things are arranged. Now let's start with some technical details. So guys, if you recall the definition of artificial intelligence, so ultimate aim of the artificial intelligence is to mimic the human behavior. That is nothing but the mimic the human brain. Just behave like a human brain. So to understand the neural network architecture, you should understand how our brain performs, right? So this is how our brain performs. In our brain, we have a number of neurons, right? We have a number of neurons, and what these neurons will do, they will process the information or input signals which it gets from different body parts, right? So this is one neuron, this is another neuron, and likewise we have a millions of neurons in our brain, right? So let's first understand how these neurons will work. And the way these neurons work in our brain, neural network has the same replica, because ultimate aim of the AI is to mimic the human behavior, right? Now let's understand. So guys, this is one neuron, this is another neuron, and there are a couple of terminologies are there. No need to focus on all of these terms. Just focus upon a couple of terms like nucleus, dendrites, synapse, and axon, right? Let's focus upon these four terms. Now, so whatever these thin lines you are seeing, this thin line kind of a structure, all of these thin lines are called as a dendrites. And what these dendrites will do, these thin lines or connections will carry the input signal from different body parts, right? They will carry the input signal from different body parts. Okay. Let's suppose you are hungry. So there is a one input signal is coming to your mind that your body is hungry. Let's say you are thirsty. You need some water. So another input signal is coming to your body like the body needs some water. So likewise, different input signals are coming from different body parts with the help of these dendrites, right? Now, second one is this synapse. Synapse is nothing but when these dendrites are connected with this nucleus, we have a, you can see this little circle. So these circles, we are calling it as a synapse. What are these synapses? Synapses are nothing but the weights assigned or weightage given to this input signal. Now, what this weightage will do? It will help nucleus to identify which input signal is having the more importance compared to the other. For example, let's suppose this is our nucleus. And in this nucleus, we are getting three signals. First input signal I1, second input signal I2, and the third input signal I3 from different body parts. And let's suppose out of these three input signals, the most important input signal is I3, right? And second most important input signal is, let's suppose, I1 and then I2. So what this neuron will do, it will assign some weight value to these input signals. For example, let's suppose it will assign the value 0.7. It's a numerical value to this input signal I3, 0.2 to this input signal I1, and let's say 0.1 to this input signal I2. So just by assigning this weight, nucleus will understand that out of these input signals, the most important is I3 because it is having the higher weight. Second important signal is I2, and then, I1 and then I2. So in that way, this nucleus will start processing these input signals. So this weights is called as a synapse, right? And then when the nucleus gets the input signals with this weight values, it will start processing these input signals. It will do some kind of a processing, and whatever output it generates, that output of this neuron will become input to the other neuron. Right? Output of this neuron is the input to other neuron. And this output is being carried forward to this neuron with the help of axon. So axon will take the output from one neuron and it will provide this output to the other neuron. So this is the way how our brain performs over the input signals with the help of neurons. Is that clear, guys? This information? Okay, great. So if you understood this, input signal flow and processing and this architecture, then it will be very easy to understand the neural network architecture. Now let me show you how the neural network looks like. Okay, so let me first show you. Yeah. So guys, this is a typical neural network, deep learning neural network architecture, right? Where you can say, you can see here, there is a stack of these bubbles. Each and every stack of these bubbles will be one layer. So this is the layer 1. This is the another layer. This is the another layer, another layer, and another layer. Within each and every layer, you can see these purple bubbles or these blue bubbles, right? These bubbles are nothing but, guys, these are the neurons. Neurons, or in the case of deep learning, we also call it as a node, right? So these are the neurons or node. Okay. Second thing, the first layer, whatever is the first layer will always be the input layer. Last layer will always be the output layer. And the layers in between input and output will be the hidden layers, right? So in this architecture, we have a one input layer, one output layer, and 3 hidden layers. In total, we have a 5-layer neural network architecture, right? Total, there are 5 layers. Out of 5 layers, first layer will always be the input layer. Last layer will always be the output layer. And the layers in between input and output, that means these 3 layers, will be the hidden layers. Understood, guys? Guys, attendance link is there, right? You can check your chat box. Okay, so this is one thing, guys. And then you can see here, guys, the role of input layer is to provide the input data. Whatever input data you have, we provide the input data with the help of these input layers, right? These nodes will carry forward the input data to the other layers. Now, whatever nodes you have on these layers, they are interlinked with, their previous layers and their, upcoming layers. These interlinkage is called as the connections. These are the connections between any of the 2 layers, right? Second thing, each and every node will perform some kind of a processing, right? So let's talk about this particular node. So what this node will do, it will take the input data from the previous layer nodes and it will do certain kind of a processing. Whatever output is generated by this node is carried forward to the nodes of next layer. Same this node will do, it will perform the processing, it will carry forward the output to the next layer nodes. Like same for this one also. Same, this node will do some kind of a processing and it will generate the output, and that output will be the input to the next layer nodes. And same output layer will perform some kind of a processing and they will generate the output. Right? So in this case, guys, if you see, your input data is being, carry forwarded from, like in this way, in a forward direction. That's why these networks are also called as the feed forward networks, because your information is flowing in a forward direction. Since these are, input information is flowing in a sequential manner, these networks are also called as a sequential neural networks. So there are multiple names given to this neural network architecture: feed forward neural network or sequential neural networks. Right? Okay. Now, apart from that, guys, as I told you, these nodes will perform some kind of a processing. Now, what kind of a processing these nodes will perform? Let's see, guys. So, guys, each and every node except the input layer nodes. I'm repeating it again. Except the input layer nodes, each and every layers node will perform two functionalities. Right? For input layer nodes, they will just, they will just pass the whatever input data you have, they will just pass to the other nodes. That's it. They will not perform any kind of a processing. They will just carry forward the whatever input information or input data set you have. Right? And nodes of the rest of the layers will perform two functionalities. Let's understand what are these two functionalities or processing will be there. So for that, let me show you from here. Yeah. Let's say, guys, this is a typical neuron I have, right? This is a typical node I have. And these are the input we are getting from some previous layer. Let's suppose there are two inputs, input value x1, input x2. Now this x1, x2 is some numerical value, right? Because the previous layer will generate some kind of a, what you can say, after processing, it will generate some kind of a numerical information. So I have something called as a x1 as a first input, x2 as a second input. And as I told you guys, for each and every input, we have the weightage given, right? Generally, this weightage value will be in between 0 to 1. But it is up to you, right? It's up to you. You can also provide the weightage value more than 1. But in most of the cases, the weight value will be in between 0 to 1. So let's suppose the first input signal, the weight value is W1. Second input signal, the weight value will be W2. Right? Apart from that, for each and every node, there will be some bias connection will be there, some constant value or bias connection will be there. And let's say that value is x0. Right? So this is what each and every node is getting the input like this. And the weight value for this bias connection will always be 1. Right? Now see, as I told you, each and every node will perform two functionalities. So let me just divide it like part 1 and part 2. The part 1 is something called as a adder function. Adder function. Right? Summation is the indication of this adder function. Whatever output of this adder function it will generate, That is the input to the second part, and the second part is something we are calling as a activation function. Right? This is something we are calling as a activation function. Guys, attendance link is there in the chat box. Please check it. Okay. Now see, guys, how this adder function, calculates the output. So the output of this adder function is, it will just combine each and every input with respect to their weight value. So it's like x1 multiplied by weight w1 plus x2 multiplied by weight w2 plus we have a x0 into 1, which is nothing but only x0. So in that way, it will just add all of these inputs. And this is something we are calling as a adder function or adder functionality of node. Now, whatever value it will get by this calculation, that is the input to the second step, which is the activation function. Right? And whatever is the output of activation function, that is the output of this particular node, which will be the input to next layer node. Now, when it comes to the activation function, in deep learning, guys, there are a lot of activation functions there. Let me just show you a couple of them. Yeah. So there is something called as a sigmoid is one of the activation function, and this is the formula of this activation function. tanh is another activation function. ReLU is another activation function. There are different forms or versions of this ReLU, like ALU or leaky ReLU is another activation function. Max out is another activation function. So likewise, we have a number of activation functions. Now we need to select based upon our input data, whatever is the best activation function is there. So data to data, the activation function will get changed. And whatever this X you are seeing, guys, this is nothing but the output of the adder function. That is the input for this activation function. So based upon these formulas, it will calculate, it will do the calculation, and whatever output is being generated, that is the input to the next layer node. Right? So this is what is represented here. Yes. So here bias is missing. It's not. So the first one is the adder functionality. Whatever is the output of adder, that is the input to this activation function. And activation function will do some kind of a calculation based upon whatever activation function you are using. Whatever output is being generated, that is input to the next layer node. That is the functionality each and every node will perform in this particular network. Right? Except the input layer node, because input layer node will only, they will only contain the input data information. And in that way, it will generate the output. Is that clear, guys? This whole process, how the neural networks look like? Great, great. What is the X0 mean? Okay, guys, X0 is some kind of a bias, or you can say some constant value is given, just like I'm sure all of you guys know linear regression equation or straight line equation, y is equals to mx plus c, right? So in this straight line equation, what is the c value, guys? What is the c value? Right, it's a constant. So just like this constant value, we are adding a constant in each and every node, and that is something we are calling it as a bias. So it's just like this particular constant value only, right? Yes. So this is what we have a typical neural network architecture, where we have an input layer, output layer, and couple of hidden layers. Now it's up to the user how many hidden layers you want in your neural network, and within each and every layer, how many number of notes you want. This is something up to you, right? So in tomorrow's session, I will show you how you can design this kind of a neural network with some sample data using Python, right? But yeah, for that, this understanding is required. Guys, attendance link is there. By the way, any doubts, guys? Any questions? Anyone? Great. So over to Amar. If you guys have any queries, you can ask with Amar related to LMS
sure.
portal or anything.
As dear participant, I already shared the attendance link in the chat box. I shared it once again just now. Please mark your attendance and show your feedback as well. And if you have any clear question for me, let me know in the chat box. Material of day 3 and day 4 not uploaded. So, okay, day 1, day 2 is there. I shared with the LMS team for day 3, and I think today is the day 4. So, you will get that material by tomorrow after unravel, okay? Or kuch guys?
So, yeah,
Okay.
just a minute, Amar.
Yes, please.
Yeah. Answer to your question, Kohli. It's not only about sending a question and getting the answers. It's about how you are sending, or like how quality questions you are sending, so that you will get the more accurate and relevant outcome from ChatGPT. And there are a lot of applications of the ChatGPT, almost each and every domain. So, and there are some, some advanced concepts will be there, prompt engineering and prompting techniques and those. So that is something we will be discussing in this particular course, right? Yeah, over to Omar.
Okay, yeah. So, Sumuna, what's your question? I didn't get the certificate. Sumuna, so you're asking me for mobile app development. You can drop an email to edl@daysta.com. Team will check your attendance and they will let you know. Ria is asking from where I can access those material. You have to visit the LMS. You will get over the LMS. Okay. And if you don't have LMS access, I'm requesting drop an email to EDL team. They will check your email and they will give the LMS access. If you are already done with your registration, definitely you had that. Sir, attendance sheet. I'm not sharing any attendance sheet. I'm sharing the attendance link one. I think there is one more question. I think I missed that. Swati is asking, I do not know how to access the LMS. Can you guide on that? So you can go through the day 1 recording via YouTube. You will get a perfect idea how to access the LMS. And if you are not able to do, then as well, drop an email. Any one of my team member will connect with you and they will help you on same. Sir, how to download the certificate? How you got to know that you have to download the certificate from somewhere? We're not informed that till now. No? Please give your mail ID. Hey, not required. My mail ID. I'm sharing that official email ID of the EDL team. Okay. I'm sharing with everybody. Okay, guys, I shared the going forward in the future. If you have any query or question, you can drop an email. Definitely, you will get the answer to your question. Hello, how can I register? Hey, we're done with the 4 days. You're on registration. No problem. I will share the registration link. Those who are looking for registration, just go ahead and mark your registration. Hi, good evening, sir. I am also not get the certificate of mobile application. So same thing. You have to drop an email to edl@textblab.com. How to get the classes permanently? I didn't get your question. Permanently means. Sir, is there any minimum percentage we need to maintain to get the certificate? Yes, Swati. 60% attendance is mandatory to get the certificate. You have to mark your attendance on a daily basis. If you are going to miss 1 or 2 days, that's okay. But if you are coming below the 60%, you are not eligible for certificate. So please make sure that. Attendance link, attendance link, attendance link. Most asked question in the session. Guys, anything else? Can you share the Gmail which I can message you about the certificate? Which certificate you are looking for, Abdul? For long time, not only this 30 days, another 3 months or 6 months. Okay, so you're looking for the full-fledged course with the XLR, right? With the placement assistant and all these things project. Yeah, Abdul, you can drop an email. So Purna, you can do one thing. I'm sharing the contact details. You can connect with the team. Will there be quiz or exam in the course? Yes, definitely. We'll have a surprise test on any day. So you can be prepared and be there on each and every session. Okay. You're welcome, Purna. No problem. YouTube participant, you are there. Any question? Sir, can you share the course browser? Nikhil, be like which course browser you are looking for? Then according to that, I will ask team to share. Oh, guys, if you don't have query or question, we're done with the day. You can leave the session. Those who have query, let me know. Will you give us certificate for these days? Yes, definitely. This is the certification course. Like which course you provide and what their costs respectively. So it's depend upon your education background and your work experience. If you're fresh or if you're from technical background, if you're non-technical background, we have couple of courses be like data science, data analyst, and full stack development, selenium testing, automation testing, digital marketing, AWS, DevOps. There are lots of courses. So our career counseling team is to check that, be like which course is suitable to you. Be like if you are from if you are from tech background but you're not interested in the code, there are lots of things. So we have to check on the same. Then definitely we'll suggest you, we'll share all these things. These all are free. Free be like guys, we're just explaining you. Be like if you're comfortable in the full stack or if you're comfortable in the artificial intelligence, so you can choose your career path. It's the perfect time to choose the career. Now that's why we're just showing you what kind of courses you have to attend and be like what is your comfort zone. So you have to pay for that courses, but it's 6 month course, and in that we used to cover lots of things. Lots of B means like from the basic to advanced. In that 3 months of training program, then live project with the AI agent company, then placement assistant assignments in the placement assistant, LinkedIn, GitHub sessions, then live interviews. Lots of things are there. So if you're looking for the same, definitely you can visit our XLR location, or else you can contact us. You can drop an email to EDL team. Attendance link. Sorry, got disconnected. Yeah, no problem. Ibrahim, I'm sharing that. Nikhil, what you're asking me, sir, can you WhatsApp me over? Yes, definitely, Nikhil. Nikhil, tomorrow, what's your free time? Definitely will connect at that time, or else one of our team member will connect and they will explain all these things. Let me share the attendance link to the Ibrahim. YouTube participants, sir, assessment कब होगा? Surprise, my dears. Assessment, it's surprise test. On any day, we'll come and we'll say that today you have to give the assessment. So be prepared, be there on every day. Okay. Oh, who is there? Navya. Sir, I did a mobile app development certificates distributed to the participant. Should we wait for the certificates? Should we wait for the certificate or mail XLR? Could you please give a clarification? Navya, we're on it. We're sharing that. Definitely within 2 days we'll share. But if you are feeling that I have to check my attendance person, definitely you can drop an email to EDL team. They will check your attendance and they will let you know. Thank you, sir. Yeah, no problem. You're welcome. Prachi, okay. Sir, this assignment have certificate, sir? I didn't get your question. Thank you. Good evening, sir. Very good evening. Assignment, there is no any assignment. There will be assessment. Definitely, it will affect on your certification. And guys, one more thing. You know, those who are going to do a top in the test, they are going to get the surprise gift from the XLR team. सर कधी मिळणार आहे सर्टिफिकेट मोबाईल ऍप डेव्हलपमेंटचं? मिळून जाईल, तुम्ही ईमेल करा. ओके. If we have no money, then we will not learn this. It's not like that. So there are a couple of options with the XLR. So you can just connect with us. Definitely will help on the same. See, skill is the most important thing. And money is a secondary part, but you have to work on your skill, then certificates, all these things to be a competitive in the market. You have to work on that part. Sir, how many marks get a score? It's not be like that. So you just have to give a assessment. That's important. Okay. Guys, in another question, it's already 9-1. If you have, we'll be there. Sir, I did not receive certificate of mobile app development. Prachi, that's what I'm saying, that drop an email to EDL team. They will answer your question. What is the status of your certificate? You are qualified or not? In how many days you will receive that? Okay. Guys, any another question? If not, then say me no. We'll wind up the session. And I hope you are enjoying the sessions every day. And you are increasing your knowledge and you're gaining your skills. See, we are at 9 to 48 participants are there. At least 8 replay should be there, guys. Yes or no? I'm not asking you to unmute yourself and talk, no? Just you have to type the yes or no, yes or no. Or are you sleeping or doing the sessions? Okay, good. Now I got few couple of the responses. Guys, be interactive and be active everywhere. Like, no sir, attending seriously. Good. How many days this class will be going on? So we're done with the 4 days and 11 more days to go. So 30 hours training program is there Monday to Friday. Okay. No doubt, sir. You can wind up the session. Thank you so much, Navya. Sir, notes nahi send karat tumhi, just lecture. Hey, we're not going to send the notes via WhatsApp or via email. You have to visit the LMS, okay? You will get each and everything. Recorded session, attendance, material, whatever are there, you will get. Don't worry, okay? Okay, then it's time to wind up the session. Thank you so much, dear participant, to joining and attending day 4. And definitely, we'll meet you on